According to the National Electrical Code, specifically Section 250.30, A1 electrical equipment must be installed in a neat and workmanlike manner. Furthermore, Section 300.3 B dictates that conductors entering a building must be protected against physical damage. Running feeders from a separate service, such as one dedicated to a well pump, through a single-family residence to reach that well would violate these codes. The primary reason is the creation of a potential physical hazard. When feeders are routed through a dwelling, they become susceptible to damage from various sources. People moving through the residence, furniture being rearranged, or even accidental impacts can compromise the integrity of the conductors. This exposure increases the risk of electrical shock, short circuits, and potentially even fire. Moreover, the feeders would lack adequate protection from environmental factors if they were to run outside of the house. Exposure to moisture, temperature fluctuations, and physical abrasion can degrade the insulation of the conductors, leading to malfunctions and safety hazards. The NEC prioritizes the safety of occupants and the prevention of electrical hazards. Running feeders through a dwelling introduces unnecessary risks that are directly addressed by the code's requirements for neat, workmanlike installations and protection against physical damage. To elaborate, firstly, consider the potential for accidental contact. Children, pets, or even adults might inadvertently come into contact with exposed or poorly insulated feeders. This contact can result in severe electrical shock or burns. Secondly, the risk of physical damage is significant. Feeders routed through a house are vulnerable to being punctured, crushed, or otherwise damaged by furniture, tools, or other objects. Damaged insulation can lead to short circuits and fire hazards. Thirdly, environmental factors play a crucial role. Temperature fluctuations, humidity, and exposure to chemicals can degrade the insulation of feeders over time, increasing the risk of electrical problems. The NEC provides specific guidelines for the proper installation and protection of electrical conductors. These guidelines are designed to minimize the risk of electrical hazards and ensure the safety of occupants. When dealing with multiple services on a property, it is essential to maintain separation and isolation to prevent potential conflicts and ensure proper grounding. Each service should have its own dedicated grounding system, and the feeders should be routed in a manner that minimizes the risk of physical damage and environmental exposure. When installing electrical systems, it is always best to consult with a qualified electrician. A qualified electrician can assess the specific conditions of the property and design an installation that meets the requirements of the NEC and other applicable codes. They can also ensure that the installation is performed safely and correctly, minimizing the risk of electrical hazards. In the specific scenario of a well pump service, it is important to consider the location of the well and the available pathways for routing the feeders. If the well is located a significant distance from the main service, it may be necessary to install a separate service panel closer to the well. This can reduce the length of the feeders and minimize the risk of voltage drop. Alternatively, it may be possible to route the feeders underground in a conduit. Underground installations provide excellent protection against physical damage and environmental factors. However, it is important to ensure that the conduit is properly buried and protected from damage from digging or other activities. Regardless of the chosen method, it is crucial to adhere to the requirements of the NEC and other applicable codes. This will ensure that the installation is safe, reliable, and compliant with all applicable regulations. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. A qualified electrician has the knowledge, skills, and experience to perform electrical installation safely and correctly. Attempting to perform electrical work without proper training can result in serious injury or even death. Moreover, improper electrical installations can create fire hazards and other safety risks. It is always worth the cost of hiring a qualified electrician to ensure that the electrical system is installed properly and safely. To reiterate, running feeders from one service through a house to another location, such as a well pump, is generally not permitted by the NEC due to concerns about physical damage and safety. Instead, consider alternative methods for routing the feeders, such as installing a separate service panel closer to the well or running the feeders underground in a conduit. Always consult with a qualified electrician to ensure that the installation meets the requirements of the NEC and other applicable codes. Ensuring that the electrical system is installed safely and correctly will protect the occupants of the house and prevent potential electrical hazards. The National Electrical Code is updated regularly to reflect the latest advances in electrical technology and safety practices. It is important to stay up to date on the latest code changes and to ensure that all electrical work is performed in accordance with the current edition of the NEC. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, grounding, overcurrent protection, and equipment installation. It is an essential resource for electricians, inspectors, and other electrical professionals. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local authorities to determine the applicable requirements. Adhering to all applicable codes and regulations will ensure that the electrical system is safe, reliable, and compliant with all applicable laws. Keep in mind that electrical safety is paramount. Always take precautions when working with electricity and never attempt to perform electrical work without proper training. If you are unsure about any aspect of electrical installation, it is always best to consult with a qualified electrician. Furthermore, it is always necessary to obtain the proper permits before commencing any electrical work. Permits ensure that the work will be inspected by a qualified inspector who can verify that it meets the requirements of the NEC and other applicable codes. Obtaining permits can also help to protect the homeowner from liability in the event of an electrical fire or other accident. Electrical systems are complex and require careful planning and installation. By following the guidelines of the NEC, consulting with a qualified electrician, and obtaining the proper permits, it is possible to ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. Let's also consider the specific types of conductors that are permitted for use in electrical installations. The NEC specifies the types of conductors that are approved for different applications, based on their insulation, ampacity, and other characteristics. It is important to use the correct type of conductor for each application to ensure that the electrical system is safe and reliable. For example, type NM cable is commonly used for wiring in residential buildings. NM cable consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It is suitable for use in dry locations and is relatively easy to install. However, it is not permitted for use in wet or damp locations, or in locations where it is subject to physical damage. Type UF cable is designed for use in wet or damp locations, and it is also suitable for direct burial. UF cable consists of insulated conductors enclosed in a waterproof sheath. It is commonly used for underground wiring and for wiring in outdoor fixtures. Type THHN conductors are commonly used in conduit. THHN conductors are insulated with a thermoplastic insulation that is resistant to heat and moisture. They are suitable for use in a wide range of applications, including branch circuits, feeders, and services. In addition to the types of conductors, the NEC also specifies the allowable ampacity of conductors. Ampacity is the maximum amount of current that a conductor can carry safely without overheating. The ampacity of a conductor depends on its size, insulation, and the ambient temperature. It is important to select conductors with sufficient ampacity to handle the expected load. Overloading conductors can cause them to overheat, which can lead to insulation failure and fire hazards. The NEC provides tables that list the ampacity of different types of conductors under various conditions. These tables should be consulted when selecting conductors for electrical installations. When making electrical connections, it is important to use approved connectors and to make sure that the connections are tight and secure. Loose or corroded connections can cause overheating and voltage drop, which can lead to equipment malfunctions and safety hazards. The NEC specifies the types of connectors that are approved for different applications. It is important to use the correct type of connector and to follow the manufacturer's instructions for installation. Wire connectors, such as wire nuts and crimp connectors, are used to join two or more conductors together. These connectors must be properly sized for the conductors being joined, and they must be installed tidily to ensure a secure connection. Terminal blocks are used to connect conductors to equipment, such as circuit breakers and switches. Terminal blocks provide a convenient and reliable way to make electrical connections. When installing electrical equipment, it is important to follow the manufacturer's instructions and to ensure that the equipment is properly grounded. Grounding is an essential safety measure that helps to protect people from electrical shock. Grounding provides a low-resistance path for fault current to flow back to the source, which causes the circuit breaker to trip and to energize the circuit. The NEC specifies the requirements for grounding electrical systems and equipment. All electrical equipment must be properly grounded to ensure that it is safe to use. Grounding electrodes, such as ground rods and ground plates, are used to connect the electrical system to the earth. These electrodes must be properly sized and installed to provide a low-resistance ground path. Grounding conductors are used to connect electrical equipment to the grounding electrode. These conductors must be properly sized and installed to ensure that they can safely carry fault current. In summary, remember that running feeders through a house to serve a separate structure or equipment is generally not permitted by the National Electrical Code. This prohibition exists because such installations can create physical hazards and increase the risk of electrical shock or fire. Instead, explore alternative wiring methods that comply with the NEC, such as installing a separate service panel or using underground conduit. Always consult with a qualified electrician to ensure that your electrical system is safe, reliable, and code compliant. Prioritizing electrical safety will protect your property and the well-being of those who occupy it.